One of the things that we don't really think about are the difference between a line and a straight line. A straight line denotes that not only is the line infinite in length going in both directions, but at no point does that line curve in the instance that we graph such a line. And because a line is in fact infinite in both directions, we can only use symbols or discrete graphs to represent a line. And so when we write a line or graph a line, the line, if we were to graph a single line, would take an infinite number of space and time such that we don't necessarily know if we have even contained in this universe. So, for instance, there is a discrete graph of a line, such as the arrows denote that it goes on to infinity or negative infinity in both directions. Now, or in one direction. Now, the interesting thing about this representation is not only that it is discrete and at no point towards infinity can it curve, but we use this geometric graph to represent a numerical system we call the number line. Well, the line is a geometric figure that is, in fact, separate from the actual symbols that denote spaces on those lines that we call numbers. So let's say that I draw 1. 1 corresponds to some point along the series or sequence of points that create the overall line, which is a one-dimensional plane. Now, depending upon the direction of the line, whereas 1 is the magnitude, the direction, given that we go horizontal like this would be the x coordinate in a coordinate system. Whereas this is the y, such that we get coordinate xy. That's how we denote a normal Euclidean plane. And we use the coordinates on that plane. Now, this itself, a line is a plane, a straight line. And so even a curved line would be a plane. But one of the way we denote positions on this line is we only use the x or we only use the y, such as the y is in parentheses. And the number symbols that we use, they respond or correspond in a one-to-one relationship where they name or nominal numbers, not only counting numbers, such that they represent the name of this space or represent this space with a name through a symbol. And so each of these points has to have a unique symbol, and yet we repeat concepts throughout the different numbers that we use and how this numerical system continues to be labeled as far as the notation. But all of those symbols in the notation are different in the 2, 3, they're all what's the word? Unique. So one of the things that you can think about is that every single symbol that we use for a number corresponds not only to a space on a line in geometry, but also to a concept in our minds. And one of the differences between Zeno's paradox in real life and Zeno's paradox in our head, and this is the difference between fantasy and reality, is that in our mind we can infinitely subdivide any number amount or value on a number line, which is actually a space, into an infinite number of subdivisions. However, we can only do that in our mind. But on paper, we can do this only discretely because we have a limited amount of space and time given that particular locality. And that's what it is it's a locality in a field is what a coordinate is. It denotes or names that specific point, coordinate point, or space. And so the symbols not only represent the space, the coordinate, and what's in our head, the concept, which is the difference between a numeral and a vector equal to the numerical value that represents the space that we concern ourselves is a vector. And vectors also have direction. So you could actually write vectors much like this, where it keeps going up by 1. And so the vectors respond or correspond to the numbers as they increase in size. But we can also think of a numerical system as being a set, such that, let's say we put 1, 2, 3, that represents a pattern, and then you put an ellipses and you have the nth term. Now this set can be closed with parentheses or open on either side or both sides in set theory, such that we created a numerical system that these do not denote necessarily a space on a line, but as an element in a set, they correspond to that space as we draw them in the set. And when we think about the concept of 0, we're saying that 0 is the origin or the midpoint of that plane, that it is in the exact center. But one of the things is that if you can't graph a line because you don't have enough computational time to graph that line, how do you know with complete certainty, or can you, and that's the thing, you can't, that this is the actual midpoint in the line, that that's the origin? Over here are the negative numbers. And so over here are the positive numbers. Now, it's really a concept that is interesting